In this lesson, we will begin looking at financial applications, and they're related to sequences and series, as we're going to see. But in order to get to that part, we just have to learn a little bit about how interest works, first of all. So let's begin with that. Interest is the cost of using money. A bank pays interest for using money in your savings account. So in other words, you put money in a savings account. The bank then uses that money to get more money for themselves. They'll pay you interest. Very, very little interest. But in theory, they'll give you something for putting your money, lending your money to them in essence. Or if you borrow money from the bank or a credit card, then you'll pay them interest. And that will always be a lot more than what they'll give you. But anyway, it's this idea of if your interest is the cost of using money. Simple interest, which is the best way to begin thinking about it, is interest that's calculated only on the original principal. And we need to know what the word principal is, but principal, let's just define that right now. This big P stands for principal. And that is the amount. Let's talk about it in terms of borrowing. No. Let's talk about it in terms of amount investing so that we're getting the money. That's much more enjoyable to think about, isn't it? So the amount invested or saved, or I guess we could say borrowed. We could put them both down because it's the same thing. So if I go to the loan, go to the bank, get a loan of $100,000, that $100,000 is called the principal. Now, capital I is the interest amount, and that is in dollars. So if I borrow $100,000 from the bank and I pay them $100 back, in addition to the $1,000 I borrowed, that extra $100 is the interest. R is the rate, the interest rate. There's always an interest rate involved. Interest rate. That is a percent. It's given as a percent, and it just tells how much interest you're going to pay as a percent of how much you borrow. So if I borrow $100,000 and the interest rate is 5%, that means I'm going to give them 5% of that $100,000 back as my payment for borrowing the money. And T stands for time. For a simple interest, that's always in years. If I want to, so here's a formula. I skipped over that. I equals PRT, which means interest amount equals the principal amount, how much you borrowed, times the rate as a decimal. So it's given as a percent, but I guess I should emphasize calculated as a decimal. So we never calculate things with percents. We always change them to decimals. So there's nothing new about that, but I just want to be clear. And then T is the time in years. So if I want to know how much interest I have to pay on a loan, if I borrow $100,000, that's my P. If the rate was 5%, then I'd write that as 0.05. And time would be how long am I borrowing it for? Because the longer I borrow it for, the more I have to pay. So maybe 2 years, something like that. Here's another formula that just changes things around a bit. If I borrow $100,000, obviously I have to pay back that $100,000 plus the interest. So I'm paying back more than $100,000. Maybe it's $120,000 or something like that. So A stands for the final amount that I pay back. It's where I add the principal, the amount I borrowed, together with the interest amount that I'm paying for the benefit of using the money, and it's just lumping it together. So again, if I borrow $100,000, if I then charge $10,000 interest, A would be the $110,000 of adding it up. Show the interest rates as they would appear in the formula R. So we're just changing it to a decimal from a percent. So 13%, the easiest way is just move the decimal 2 places to the left, or you could divide by 100 on your calculator. But this is a basic mental math type thing. 13 can be written as 0.13. 0.2 or 2.5%, if I move the decimal 2 places to the left, would be 0.025, right? If I've got a single digit percent like this, I know there's a decimal after it. But if it's just 2%, there's always going to be a 0 in front of it before the decimal. So maybe it would have been good to do another one. Let's add a D up here. If I had 5% interest, that would be 0.05. Again, just moving the decimal 2 to the left. We can have a decimal in the interest rate. That just, comes after the 2, as you can see in this case. 0.5%, it's already got a decimal in it, but if I want to make it as a decimal, as a non-percent, then I need to, again, move that decimal 2 places to the left. So that'd be 0.005. So that's half of 1% as a decimal. Also, as I mentioned before, time is given in years. So sometimes you might be told the time of a loan in something other than years. You're going to have to convert it. So you need to just know that 1 year is the same as 12 months or 52 weeks or 365 days. So 24 months, since there's 12 months in a year, then we would have, we'd just divide by 12. So 24 months divided by 12 is 2 years. 8 months, if I divide that by 12, then I'd have 8 over 12. But I'd reduce it to lowest terms, so 2/3 of a year. Or for this formula, it might even be most useful to use it as a decimal. It'd be 0.6 repeating years. 14 weeks, well, I would divide that by 52, wouldn't I? And again, probably best to have it as a decimal. 14 divided by 52 is 0.269. I'll go to 3 decimal places here. I do want to carry a few decimal places just because if I round it early and if I round a few things, it's going to have a significant impact on my final answer. So I'll try to carry a few decimal places. 82 days is going to be the same as 82 divided by 365 years. 0.225 to 3 decimal places. So I have to have it in years in order to use this formula. So it's pretty simple. That's why it's called simple interest. It's not hard to calculate. It's straight multiplication once you've got things with the right units. How much interest is earned if $2,000 is invested at 4% simple interest for 26 weeks? So 2,000 is my P. 4% interest means that R equals 0.04 as a decimal, and 26 weeks is half a year. So that'd be 0.5 years. Remember, there's 52 weeks in a year. So there's all I need. The interest earned, and it's earned because this is an investment, is equal to 2,000 times 0.04 times 0.5. $40. How much is the investment worth after 26 weeks? Well, they're asking you to find A in this case, the final amount, because you own the original $2,000. So that's your principal plus interest is the $40. So now you are $40 richer and have an investment worth $2,040. What principal is needed to have $500 in interest in 2 years? invested at 2.5% simple interest. So this is just taking, we can always just take this I equals PRT formula and rearrange it. So in this case, they're saying what principal is needed. So if I were to rearrange this formula and isolate P, I could divide each side by R and T. So P equals I over divided by the rate divided by the time. And so what principal is needed to have $500 in interest, so that would be my I value, right? 2 years, that would be my T value. 2.5%, that means that R is going to be 0.025. So the principal that I would need to make this work out would be I, 500, divided by 2 times 0.025. So again, I can either find out what's going on in the bottom. I could simplify the bottom first and then divide, or another way, the way that I prefer because it's easier, I already forgot the amount, 500, that I prefer because it's easier is I start with what I'm dividing, and I'll just divide by each of the things on the bottom separately. So I'll divide by the 2 for 2 years, and I'll also divide by the 0.25. So divided by 2, divided by 0.25. And that would give me 6.25. Now, actually, I just want to make sure this calculator is a little different from the one I would normally use. I don't know if I trust that. Let's try this way. Yeah, this calculator is different. Sorry, I take that back, what I just said. On a normal calculator, the handheld scientific ones, I just hit divide twice. This calculator works a bit differently. There we go. Yeah, 6.25 doesn't make sense. I forgot even what I was calculating. Principal of $6.25 would not do it, would it? $10,000 makes sense. I'm just pointing out that this calculator, well, it follows the same order of operations, of course, because it makes things into actual expressions like you can see like this. That's what I want. Whereas on another calculator, if I was just doing 500 divided by 2, and then I also hit divided by 0.025, that should get me the same answer of 10,000. You're going to have to play with your calculator a little bit to see what I mean. Figure out exactly what buttons to push to make it work out. So I would definitely, as I always do, I'd encourage you to work out any of these problems with me and type them in your calculator and make sure you're getting the same answer as me. What rate of simple interest is needed? So this time we're being asked to find R. So if we rearrange this again, this time if I isolate R, now it's going to be P and T that's going to be on the bottom. I'm going to divide both sides by P and T. Same thing, just R and P have swapped places. And so $7,000 is my principal. $10,000 is my final amount. They're not saying that's the interest, that's the final amount. And 5 years is my time. So with this, I can figure out what interest is, right? Because I know that A equals P plus I. So 10,000 equals 7,000 plus I. Rearranging that, 10,000 minus 7,000 means that the interest has to have been $3,000. So R is going to equal the interest, the $3,000, divided by the principal, $10,000, times the time, which was 5 years. And again, you're going to have to type it in how it works best on your own calculator. But for mine, 3,000 divided by 10,000 times 5. It was 5, wasn't it? Gives me 0.06. Well, what does that mean? That, of course, is as a decimal. If I wanted to change it back to a percent, I could move the decimal place 2 places back to the right, and it becomes 6%. How long would it take for $1,500 to grow to $2,000 at a simple interest rate of 3%? All right, so again, I equals PRT. If I rearrange this, then I divided by P times R equals T, isolates the T. So this is my P. This again is my A. This is my, well, my rate is going to be 0.03. So again, from this, I can figure out that the I has to be $500. I could show it, but we can also just think about it. If I started with $1,500 and I ended with $2,000, then the interest rate, the only other component is the $500 that must be the interest earned. So there we have it. So T, the time in years, is going to be $500 divided by $1,500 times the rate of 0.03. Nope, let me clear that. 500 divided by 1,500 times 0.03. 1.1 repeating, or 11.1 repeating, my mistake. Let's just say 11.1 years, or we could even just say about 11 years. Okay. I actually think that I want to make, you talk about compound interest as a separate topic. I feel like doing simple interest, just being clear on that is a good first step. So I'm going to stop here. I'm going to make a separate recording for the compound interest part, which means that just looking at the homework questions, any of the ones that involve, say, simple interest are going to be good ones. I guess there's only a few of them. Okay, I'm backtracking. All right, let's carry on then. Just sometimes I feel like it's good to chunk things, but you can do that yourself, right? You can always pause the video and answer those questions, and we can chunk it for yourself. All right, so let's look at compound interest. We know what simple interest is now. The main thing is that the interest is always calculated only on the principal. What makes compound interest different is that they don't just add interest to principal, they add interest to other interest that has been already calculated. So if I have some sort of loan where I borrow $100 and I pay 10% interest, just to keep it simple. After 1 year, I'd have to pay $10 interest, right? 10% of 100 is $10. But if I keep this loan for a second year, I'm going to add that $10 in. Now I owe $110. At the end of year 2, I'm going to calculate another 10%. Well, now I'm doing 10% of that 110. So the interest for the second year is going to be $11. And then I'm going to add that back in. And then for year 3, that means I'd have $121. So 10% of that would be $12.10, and so on. So that's a big difference. Really what it does is it changes something that's an arithmetic situation, because adding the same interest year after year, or yes, I guess year after year, if it's only calculated on the principal, I'm going to add the same interest year after year. It's changing it from arithmetic to geometric. This becomes a geometric sequence, really. And therefore, it's going to involve exponents. It's really going to be very much like an exponential function. The formula for compound interest is A equals P times 1 plus I to the exponent n, where A is the amount, or the final amount. So it's the final amount that again, let's talk about borrowing money. If I borrow $1,000, obviously, when you include interest in there, I'm going to have to pay back more than $1,000. Well, A is that total final amount that includes the principal, the amount borrowed, plus the interest accumulated. Now, we use slightly different variables for compound interest. Instead of using R, we use I, little lowercase I. And lowercase I is the interest rate per compounding period. Because it's not always going to be calculated once a year. Sometimes it'll be calculated twice a year, 4 times a year, every month, every week, every day. So it depends on how often it's being calculated. And so if there's 10% interest per year, but I calculate the interest 12 times per year, then I would divide that 10% by 12, and I'd just give that percent once a month. It would still add up to 10% in a year, but it's broken into smaller chunks. And n is also a new variable for compound interest. N is the number of compounding periods. So again, let's say I borrow money for 10 years, but it's compounded monthly. Well, there's 12, that in other words, they're going to calculate the interest, a smaller interest 12 times a year, and I'm going to do that for 10 years. They're going to actually calculate the interest 120 times. That's what n would be in that example I just made up. So we have to be aware of what I and n are to do compound interest. And because that goes directly into the formula. The formula is easy enough to use if we can calculate what I and n are. P is just the amount we're borrowing. So here's some common time frames for calculating interest. So if you see something that says annually, it means they're calculating the interest once a year. And so whatever the annual interest rate is going to be what I is as a decimal. And they're all going to be as a decimal, but I'm just going to write that for this one. N is the number of years. So if you calculate the interest once a year, then n will just be however many years have gone by. Semi-annually means twice a year. So I take half the interest rate, but I do it 2 times a year. So if I was 10% interest, I'd do 5% interest maybe in January and another 5% interest in July. Still adds to 10%. But I'm breaking into 2 portions. So I is only half as much. But that's balanced out by the fact that we're going to do it twice as many times. So if it was for 5 years, n would actually be 10. 5 times 2 gives me 10 times they do it. Quarterly is 4 times a year, following the same pattern. Monthly is 12 times a year. We'd follow the same pattern to get I and n. And we can do other ones, like I said, weekly or daily, but those are some common ones. For each situation, determine the interest rate for the conversion period and the number of conversion periods. So in other words, they're asking us to find I and n. That's it. Because once we know I and n, the formula is really easy. So an investment of 10% or at 10%, this here /a means per annum. It means per year. So when you see that, don't worry about it. Annum is just Latin for year. So it's saying there's an investment that you're paying 10% interest per year. It's compounded. What we have to look for is the key words. Like, again, these are the words we're going to see in the actual question. So if we see semi-annually, we can go back and know that that means that they're going to calculate the interest twice a year. And then I can see how I would get, how I is going to be related, how n is going to be related from that semi-annually. So 10% twice a year, I is going to be 10% as a decimal, so 0.10 divided by 2, which is 0.05. And n is going to be the 11 years, but twice a year. So the n is going to be 22 times. That's how many times they're going to calculate the interest. Once we know those, we plug them in the formula and we're good. So 6% per annum compounded. The key word is monthly here. So I is going to equal 0.06, that's the 6%, divided by 12, because monthly is 12 times a year. And that gives me 0.005. I just know that one from experience. But you can check it on your calculator. N is the number of years, which is 3.5 times 12. Again, because I multiply times 12 for n. So whether it's monthly or semi-annually or whatever, you'll notice that these numbers always match up. Divide by 2, multiply by 2. Divide by 4, multiply by 4. Divide by 12, multiply by 12. So in this case, it's 12, right? So I divided by 12 to get I. I'm going to multiply the years by 12 to get n. 3.5 times 12 would be 36 plus 6. That should be 42 times the interest calculated. This one is compounded quarterly, so 4 times a year. So sometimes we get these big decimals. We're starting with 3.75%. So change that to a decimal, 0.0375, and then I divide it by 4. That one's not so easy to do in my head. I will definitely go for the calculator on that one. And I'm going to have, a few decimals. I'm not going to round this one. Absolutely don't round. When you're dealing with interest rates, rounding will make a huge difference because it's exponential. So keep all your decimal places, at least a lot of them. I'm going to keep all of these. 0.009, I think it was 735, but I could have been wrong on there. Let me double check. 375, got them reversed. Okay, so there's my I for this one. I would keep all these decimal places. And N, 27 months. Again, I have to think about that as years, first of all. So 27 months is the same as 2 1/4 years. So I have to start with years there. And then I can do N equals 2.25. And quarterly, again, means I multiply by 4. So that'd be 8, 9 times. Once I've got those, then I can put them in my interest formula. We can use the interest formula to calculate the total amount, future value of an investment. Note that unlike the simple interest formula, which only calculates the interest, compound interest formula calculates the interest and the principal together. So that's also important to bear in mind. Compound interest formula calculates the principal and the interest together. Remember, for the simple interest formula, we had this formula way up here at the top that said final amount equals the principal plus the interest. We had to get I first and then add it back to the principal. Well, the compound interest formula, this one here, has it built together. A is given here. All I do is take the principal and multiply it times 1 plus I to the exponent n, and it gives me that final amount. If I wanted to find the interest dollar amount, I would have to actually subtract the principal from the final amount to get it. For each situation, determine the amount and the interest earned. So that's exactly what I was just talking about. So I'm going to use this formula again, just rewrite it here. A equals, final amount equals the principal times 1 plus I to the n. So first I want to find A, the final amount. So let's identify some stuff here. So principal is $2,000. That's what's being invested. 7 years. So N, let's get the keyword here, semi-annually. So N is going to equal 7 years times 2 for semi-annually, so 14. I is going to equal 0.025 divided by 2, again because of semi-annually. So if I want to get the final amount, this is part I, then A is going to equal 2,000 times 1 plus I. No, I'll write it this time. Normally I'll just combine them all at once because it's pretty obvious, to the exponent n. So by what I mean by combine them is, normally I just, instead of writing 1 plus this, I just write 1.0125, because obviously when I add 1 to some decimal with 0 at front, the 0 just becomes a 1. And then I type it all in at one time. 2,000 times 1.0125 to the exponent, I think it was 14, but I'm going to have to double check that, yes. $2,379.91. $379.91. That's the final amount. How much of that is interest? Well, the part that we didn't start with. We started with $2,000, so the interest is going to be the final amount minus the principal. So $2,379.91 minus 2,000 means that it's earned $379.91 in interest. Okay, let's try B part. So the principal in this one is $1,234. The keyword is weekly, which means we're going to multiply by and divide by 52. So for n, we're going to take those 5 years and multiply by 52, which would equal 260. For I, we're going to take that 0.067, 6.7% as a decimal, divide it by 52, and we're going to get a big long decimal. I'm going to keep all those decimal places. 0.0128885. Now, I did round a little bit, but you can see I carried a lot of decimal places. Let's just make sure I got, yeah, that's good enough. All right, so A is going to be 1234 times 1.0012885 to the exponent 260. Let's get rid of this because it's now sort of in my way and cluttering things up. Okay, that's just plugging in the appropriate values for everything. Maybe what I'll do, and I often do this, is even though I only wrote down some of the decimal places, I'm going to use what's still on the calculator in the next part. So I'll use the 1234 times, and I can actually do in brackets 1 plus the previous answer, and then do that to the exponent 260? Yep, 260. And I got 1,724.67. Again, just double check that I didn't invert anything, and I did. 1,724.67. I did it again, reversed some numbers. So slippery. Let's see if I got it right this time. 69. Not sure I came up with 7 either. Always good to double check your work. So that's the final amount for part 1, or part I. For part I, again, is the interest would be the 724.69 minus what we started with, which was the $1,234 principal. $490.69. Last example, in what feels like quite a long lesson. Linus invests $3,000 at 6.5% per annum, compounded quarterly, 4 times a year. How long will it take for the interest or for the investment to grow to $5,000? All right, so this is P, the amount we're starting with. This time they're giving me A, the final amount, and I can calculate I from this. So, all right, P equals 3,000, A equals 5,000, I is going to equal 0.065 divided by 4. $0.01625. And I need to find out what n is, right? So we know A equals P times 1 plus I to the n. So 5,000 equals 3,000 times 1.01625. When I add the 1 to the I together equals n. Again, this is one of those solving for an exponential equation type things where I'm just going to use guess and check, but I can simplify first by dividing both sides by 3,000. So 5,000 divided by 3,000 is going to reduce to the same as 5 over 3, which would be the same as 1.6 repeating. So about 1 2/3, in other words. And I can just try different exponents on 1.01625 until I get something close to 1.6 repeating. 1.625, yes. All right, so let's try some different exponents. Let's try 20. Too low. So let's try something higher then. Let's try 30. Okay, getting closer, but not quite there yet. Let's try 35. Oops, I did 335. Too high. 32, that's close. 31, it's a bit too low. Okay, so let's go with 32. So by some trial and error, I got n equals 32. That's not the answer, though, because the question never said, what's the n value? It said, how long? So I have to convert n back to a time. Remember, this is an investment that involves quarterly calculations. So n is 32 quarterly calculations. So for 4 times a year, they're calculating the compound interest for 32 times. So time, in this case, is going to be 32 divided by the 4 times per year, which equals 8. And so it's going to take 8 years for this investment to grow from $3,000 to $5,000. And I believe that's the end. Like I said, this is a long lesson. And take a look at these questions, of course, and see what you can do.